Okay, I want to talk a little bit about different development platforms and the integrated development environments. Some development platforms encapsulate the integrated development environments. So we'll have a little chat about all of that kind of thing. I want to start off with this. I'll have up in your week 5 information, just talking in general about the STM32 cube uh, ecosystem, and it says making STM32 development easier. If I can zoom in a bit. Okay, ST has acquired a bunch of technologies. They have a lot of tools. They've been trying over a number of years to kind of consolidate some of it. So they have, uh, and they still do, and I'll show you where. They have a lot of applications that are downloaded when you have the development environment all downloaded, and they have um, if you want to play with USB or you want to record audio, they have those development, those packages, those examples. One of the things that's always been frustrating for quite some time is that you go and you have an example and you go, oh, great. Now I want to add an A to D or add a DAC or, add some USB. And the engineers that did those examples didn't use the Cube IDE, and so it makes it hard for you to add things. You have to go and make the structures yourself and uh, put all of that in. So they're working on it. They know they had things all over the place, and every once in a while I'll go and look at some of the different examples and see how easy it is to integrate it into what we're doing. One of the things, quite a few years ago, they came up with the STM32 CubeMX. And CubeMX allowed you, very much looks like the Cube IDE you're using, and CubeMX is actually installed on all the machines in the lab. And so that does everything that you're kind of used to as far as graphically going and selecting everything. Does the same thing, generates example code. But you need to use it with another compiler. So it generates all the code, but it doesn't compile. That's why some of you that fired up CubeMX, we were stuck. We couldn't go farther. You needed the Cube IDE. So CubeMX will generate this code and generate a project for you. And one of the things in one of the tabs of CubeMX is it says, what's your target? And there's different targets. We can do for a compiler development environment called Kyle, Atolic, which ST bought and put into the STM32 Cube IDE. That's MX and Atolic all in one. Before it was really working well, what we would do is fire up CubeMX, then open up Atolic and import your project that it generated and then compile it with that. If you're using Kyle, which is cost a few $1,000 to license that, depending on the features and things that you need. Or there's a free version. I think you can go under 32K of code, but you use CubeMX. It makes the project for you. In one of the tabs, you say you want it to be Kyle, IAR, which is another one, Atolic, which is just like if we did it in the IDE. So you can still use the stuff we've been doing if you want to use another development tool. And you'll find examples out on the internet of interesting projects, and people have used some of these other development environments. And so that's where CubeMX comes in. And again, then ST 4 or 5 Christmases ago, I had that year had bought Atolic, which was this IDE that could be used for ARM processors from across the board. And so what they did was they took out support for everything other than ST's products, and then they gave it away for free. So what would have normally cost you around 4 or 5 grand They just said, here you go, all the full development tools. If you go and use Kyle right now, the free version is limited to 32K. And then same usually with IAR and a number of the other different development packages. One of them, I think IAR might actually be limited to 12K of code. And so when you start bringing in different libraries, like when we do the graphic libraries and stuff in a few weeks, you're going to find that we're easily 100K of code. The other kind of development tools, they have they had a package called ST-Link. ST-Link is the bootloader firmware that's in this chip here. And ST-Link V2 is what you're using. And they had a standalone package. I think they called it ST-Link 9 or something like, but they had a graphical environment that would allow you to take your executables and be able to load them onto a unit without having to fire up your IDE and do all of that. Since ST-Link V2 was out, they emulate a flash, a USB stick, and so you can just drag and drop a binary file on there and it will program it. So you can go find in your debug environment, find the binary file and just drop it over and it will program. And it actually gives you a little text file that says whether everything's good or whether there was an error and things. ST32Cube Programmer takes that ST-Link application and then puts a whole bunch more features and things in it. So you can erase individual sectors. You can read in the code and dump it and do all sorts of things. Sometimes you'll have applications that might want the STM32Cube programmer to be installed, and they're going to call command line tools. So the STM32 programmer also has the ability for you to script programming and do that kind of thing. And then the STM32 Cube monitor is what I've asked you in this week's lab to go and basically look into the executable, find out where the addresses are, and you're using that debug silicone on the chip to update your data, put it on different graphs. They had a previous version of this, which did kind of what we were looking at, but didn't have all the features that Node-RED has that's in the new Cube monitor, Node-RED being this open environment to be able to make interesting desktops and with low code kind of drag and drop things, be able to put gauges on the screen and parse data. It also gives you in the Node-RED a JavaScript programming ability as well. Okay, so that's a bunch of the different tools. One other thing somebody mentioned yesterday as well, the STM32 Cube monitor. There are a number of different monitors, and they unfortunately name them kind of the same. And so we're looking for just a straight monitor. They also have a power monitor. They have a motor control monitor. They have some motor control application boards, and it will allow you to run a motor and look at the different features in it and be able to affect what you're doing as far as tuning with PID algorithms and things. You can set all of that stuff up in one of the power monitors. They also have an RF monitor, and they have some wireless chips, and they will give you some features in being able to monitor like Bluetooth packets and things like that, which is similarly named on the same page for download, but not exactly the same application there. One of the things they've also done is they've said, hey, we have a bunch of these packages that are more integrated. They have some examples that aren't integrated yet. They have a bunch of packages that are integrated. And again, over in the IDE, if we go and look at software packages, you can go and download the different software packages. And so that gives you an ability to go, let me just go over there and see if we can fire one up. That gives you the ability to use some of the different things they have um, artificial intelligence package. And so you could go and use TensorFlow in Google Colabs and generate a model to um, sense vibration, what's normal for a motor, and then if something's starting to go, a bearing's starting to go, have it trigger that you detect an anomaly. Well, you can then develop that model on a PC in Google Colab, for instance, and then shrink it down, and they have a package that'll let you put it onto an embedded device. And so, and do that kind of stuff. Okay, let me just go to, let's go to it doesn't matter, GPIO. We'll just launch one of these for a second. So all of these packages are available under the software tools. Most of them aren't downloaded by default. In fact, I don't know that any of them are downloaded by default, but you can go and say, I'm using different features. I'm using the accelerometers. I'm using, there's a GPS that they have available. And so if we look at software packs here, and I go select components, hopefully, come on, let's manage. Okay, so under manage software packs, we have different packages and it depends on the family. Now we are an F4 family, for instance, and if I go here, that's saying, hey, I've got the latest package. So if you are using this, it goes and checks and it says, hey, there's a new set of firmware available. So it could have features, bug fixes. It has the HAL API for the uh, one where you're using, and all the examples. And if any of those are changed, that's what gets downloaded over here. Then in under ST is all the different packages. ST provides themselves, and Xcube AI is this artificial intelligence thing. This is a low code template algorithm builder. Um, this here is for some different types of sensors. Just lately, just in the past year or so, they've been, I guess, coupling with Microsoft. There's an Azure RTOS. Typically, they've used free RTOS, and free RTOS is available for PIC microcontrollers, for just about any different microcontroller out there. Um, uh, some different um, uh, companies have put a version of free RTOS in ROM and certified it for medical equipment, and they call it safe RTOS. And so you can be sure that the RTOS isn't going to do anything, and it's valid to use in life, potentially life-altering equipment like maybe heart pumps and all of that kind of thing. And so Safe RTOS is a version of Free RTOS. Free RTOS is available here. But in the last year or so, I haven't really played around with any of that. There's an Azure, Microsoft Azure RTOS version. And so they've got all sorts of ones available, and it's all there for you to download. If you were using any Bluetooth modules, there's a couple of different types of Bluetooth modules. Again, those packages are there. This is to use a TFT on some of your units. There's a GPS, there's the MEMS, any of the micro machine motion sensors, NFC tags, some sub gigahertz 900 meg type systems. TOF is time of flight. So those are those little, I think you might even have from Wayne one of the little laser, ST makes this laser emitter, laser diode emitter detector. It's kind of like your ultrasonic thing from 130, except kind of more modernized. And so that's what the TOF is. This one is interesting. We're going to look at another graphics package that doesn't pop up kind of here, that they start next week we'll look at, called MWin. And in fact, ST's licensed version is called STEMWin, ST's MWin. And so we're going to use that one. They also have another package called Xcube Touch Graphics, which puts a whole other application together, and you can drag and drop some graphics, generate C++ code. Isn't quite nicely integrated into the Cube IDE yet. It gives you some challenges to make it all work together nicely. It can be done, but it's not nice and seamless yet. But the graphic environment in touch graphics, if you develop drag and drop and you have, let's say, a 7-inch screen and maybe you have one of their development boards that it directly supports, you can build all of that, say, program your target board, and it will call the Cube programmer I mentioned if it's installed, and it calls the compiler that was all done from your IDE being installed, and just generates the code and directly programs your unit with the graphics and things. I actually should have brought an example of one down on a little screen using that. So there's all of these different tools available. And then if I go, we'll just close that one there. And then let's hopefully it'll come up now. Oh, no, not that. Might not let me just select software components. So here's the screen where you get it. There's also ST stuff, and then there's Sager and a number of others. So Sager has their own real-time operating system. This company called Robots also have a Unison RTOS. Those are all available, and I just go install, and then it will put in the graphical environment. Let me select it, put the required initialization for the different functions, and then just like we've done before. So if I have, depending on the Bluetooth module, I can go and install it. If I go Xcube AI, I go install it, and then there's some samples that you can go and use. So there's all of this stuff is just there. Most of this, like I say, they don't want to install all of this stuff if you're never using it, but all of that is available. Okay. Well, let's just go down there. So we have they're really going heavy into the Azure stuff. I haven't looked at it. Mostly it's been free RTOS before that. It says easily get the most out of STM MCUs for drastically reduced development cycle. And so we have the framework. It runs GCC compiler. Most of the things they have there are free of charge. For instance, if you use the graphics and things we're using, either the Touch Graphics, which they bought that company, or the MWin, which they licensed off Sager, then it's free for you to use even in a commercial application, which is very handy. They also have a bunch of things that haven't been integrated in there, a bunch of motor control things. So if you want to develop a three-phase or brushless DC or different motor control. They have a number of different tools available for you to use. They're trying to integrate everything so you can get it from that CubeMX graphical environment. So it says here there's a bunch of different expansion packages from them and then from their partners. It's sometimes kind of hard to find. They have on their website, if it's called Xcube something, it's usually ST stuff. If it's some other vendors, it's usually iCube. I'm surprised Apple didn't go after them for that, but anyway. So we have our free RTOS, we have our wireless Bluetooth, LoRa. We're going to be looking at a little bit LoRa, some of the different Zigbee technologies, Sigfox, and I will talk about more of those kind of things coming up. As far as their microcontroller packages, again, if we go and look at the HAL, whenever we go and generate new things, there's a HAL API. Anything they do in there, it downloads the latest version from ST's site through the IDE. And we have a bunch of different microcontrollers in the family. So main microcontrollers, you have F1, F3. The difference from the one we're using an F4, which has the digital signal processing hardware multiply math available. The Cube MP is to deal with more of micro processor than microcontroller. It can run Linux. For instance, they have a version of Linux on that. And then they have a bunch of ones that are similar. These are pretty low power, the F4s and all of that, but they also have a ultra low power, which are the L4 series. So if you need something to really go battery life long term, they have the L4. And then they have a few wireless chips as well, mostly Bluetooth or into the 900 megahertz controls. I like this here, showing you the different middleware. Again, free RTOS. Up until very recently, you see a lot of Azure RTOS, but free RTOS, fat file system. It's all there in the drop-down menu. So if you want to be able to read and write to SDHC cards or USB cards and use the file allocation tables, all of the libraries and stuff are able to do it. We can use the TCP/IP stack. Again, there is Ethernet on your board. You just need a physical interface to be able to connect the network card. And then there's a bunch of secure socket handling. And then we have different middleware. We have Bluetooth stack, Zigbee stacks, the OpenThread, which is different wireless interface standards. LoRa WAN, we're going to talk about it using our little LoRa board rather than the chips that are on here. It also has the full libraries for the USB host and device. Depending on the ST chip, you can also get TouchSense. One of the project groups is building a synthesizer, and they're using TouchSense with an external chip on the one that they're using. But so you're wanting a capacitive touch, so you just put pads. You could even put pads under glass and then have it recognize it like they're buttons. And so certain ST boards, the chips are able to have that advanced A to Ds that understand that capacitive touch. And so you can use some of that as well. StemWin graphics stack is the one that we're going to look at in about a week. I think the latest price for the stuff that is available already downloaded, that you've all downloaded, is about 12,300 or so US. If you went to go to MWin and say, hey, let me have a look and use it in my systems. As far as kind of another picture of it, we're using STM32 HAL API, which is there. Now, on top of that, there's board support packages. When the first couple of labs, you said individual microcontroller, and so it was a bare chip. It didn't know what it was attached to. We can also go and say, hey, I know what, I have a discovery board, so I want to use the discovery board, and yes, initialize all peripherals, and all of a sudden it was a lot fuller, had a lot more software in behind it, but it said, I know you're using a discovery board, it has all these features, I'll initialize all the peripherals so you're ready to play with the board and use all the different features on it. It put a bunch of code in there I'm not using in some of the labs that we're doing. One of the reasons I did it, had you do it, was because it also gives us a graphical indication of all the pins probably I shouldn't touch because there's other things on the board that might interfere with things. And so we did that. Now, HAL often calls in CMSys, which is a little lower. All of these are different layers of abstraction. CMSys is an API that allows you to program your microcontroller. They came up with the HAL API to have it more uniform across their families from the F0 to the F7. So if you use that and then retargeted your code to a different microcontroller, the API shouldn't break going in that. So again, under ST, there's this licensed StemWin. There's also a bunch of audio. And so in the DSP course, you're going to be doing using another tool to be able to develop DSP applications, and you're going to use the DAC on the board and the digital microphone, or just using input data going in and doing some different things with it. And so there's another graphical tool from another company that will allow you to utilize that board and use some of that. ST also provides some audio libraries so that you can integrate it. It's already downloaded. You already have access to them. Same with the USB. And again, touch graphics is another. Those are two different graphical applications. So a bunch of stuff available. And then again, they also give us a lot of, it's really kind of used to be really difficult or really expensive. They used to have evaluation boards. Most companies had evaluation boards that were $300 at least, if not more. That had maybe a graphical screen, maybe not, and it had everything with their chip on it. And you could go and test out all of your different things. Nowadays, a lot of companies have these discovery-like boards, Nucleo boards, discovery boards, where if you went to build this board, it would cost you far more than if you just bought the discovery board. You'll get from different manufacturers 10, $20 for a board that has tons and tons of features. And so it's kind of nice in that. I like this screen in that it gives you what's available. Again, if you look, we have the F4 and we see that there's low-level APIs, the HAL APIs, and you can target per, you see that something's running a little slow. You might not want the abstractions of that API, and so you can go even faster performing on HAL by saying, when I go and use SPI, I want you to use the low-level drivers. What you're giving up is that if you then target and write your code using the low-level APIs for SPI, if you moved it from the F4 to the F7 or down to the F0, you have to redo that because they're different. They don't span across the different families. Okay, but they perform faster. So there are low-level APIs for some of that as well, and that gives you just a nice overview of kind of the things that are available. We're just sticking to the excuse me, the HAL APIs. Again, as far as different expansion packs, Xcube and iCube are available, should be able to be imported into the Cube IDE with, and it's Xcube if it's ST stuff, iCube if it's third-party packages, and they have some samples. For instance, if there's a third-party package that uses CAN bus to talk to any vehicle from 2002 on, talks CAN bus. So they have an application set just for that. Xcube packages, they have their from ST, like the touch graphics interface. Function packs haven't quite got into the graphical environment. You have a bunch of them downloaded with you, and you can go and run those samples, but it's a little trickier than to get an IOC file to add your own features on it. You kind of have to go and install put in the structures and enable all the different, let's say, GPIO or different features yourself. Again, Azure, I haven't really looked at it, but they've made some deal with Microsoft, and there's an Azure RTOS that they're really promoting right now as well. Other companies you'll see in the software expansion packs, Unison, Wolf SSL, secure socket layer. Again, the CAN open is a CAN bus, and MBOS another. So this is an RTOS, and the MBOS is another RTOS from different companies. So if your place you're working for has already been familiar with that OS in a different tool set, you can use it as well. The MBOS is, we have Sager and Robots and a bunch of the different ones. And again, just looking here, you can go search for these different Xcube audio. If you're wanting to play with audio on the F4 board, for instance, you can go Xcube audio, or you want Xcube USB audio. So you want your discovery board to act like a USB speaker, for instance. You can put that on there as well, and that's just using their APIs and firmware. when you get into the DSP class, you'll use this, and you'll use another tool that has graphical blocks for putting in filters and all of that sort of thing. And then it will generate the code, compile it, and put it down to that target board. And then, yeah. A couple of LoRa we'll talk about more. Sigfox is LoRa's is designed by Semtech, and they have the license for that. There's a bunch of technology using the LoRa, like LoRa WAN, which is all open. Sigfox is kind of, they've built out a lot in Europe, and it's very similar. It's a sub-gigahertz wireless, and it's designed for low data rate. Both of these, this one you pay per device kind of to use the network. This is free to use on the network, but you're looking at, for instance, long battery life, low data rate, and so you could in line of sight, for instance, in either one of them, you could get kilometers of range. You're not pushing audio, you're not pushing video, anything like that, but you could build sensors for water metering or something like that, and then be able to transmit it, and line of sight, you can get, like I say, some kilometers out of it. In fact, we'll look at it more, but I think the record, somebody put a LoRa module in Europe in a hot air balloon, and they got hundreds of kilometers, just off a standard unit. In fact, again, in the LoRa, some people in Europe, some I think college students or something, put together some satellites, some little Pico satellites, and got them launched. And you could pick up, the antennas didn't unfold properly, so you needed a little better antenna. But there's these units that, I don't know, every 90 minutes or so circle around the world, and you can pick them off with the modules that you have, with a little better antenna, but with the modules that you have, the little else one with the OLED screen. And these are satellites that are, circling around the world. They're this year supposedly launching a couple more satellites that have fixes for the antennas. But that's kind of interesting. The idea being that you could be almost anywhere in the world. If you know when the satellite is coming over, you could awake. You could push a small message, and then when it gets over to a station, it will relay it. And we'll talk about some of that stuff when it comes up a little bit more. So again, some of these other packages are not kind of integrated into the IDE yet, and some you can go and download and add on. And so we have, talking to IBM, talking to Google Cloud, talking to Microsoft, talking to Amazon, just talking in general to the different wireless interfaces. So you have all of these different ones on here. If you're doing anything to do with micro sensors, like the gyros or the accelerometers or that kind of thing, you're looking under the motion. AI, again, if you build a model to be able to recognize a person, you could generate a small version of it to put inside your F4 board, and you put a little camera interface. This does have a little CCD camera interface. I'll bring in the sample. I'll show you. I've got a camera interface and a little LCD going. It has all the smarts to be able to do that, and it has the what's known as an FSMC module to go out to a parallel display. I have a 7-inch display, for instance, on it and all that. It takes a bunch more wiring. We're going to use the SPI interface just because it's a little less wiring. But it has, like, for instance, vision abilities and things like that as well. So again, a whole motor with graphical environment to help you tune motors. And depending on what type of motor you want, there's different boards and things available. So we have all of those. And so it's just showing you all of the different, there's so much stuff that they have available. Sometimes it's hard to figure out kind of what's there, what's available. If it integrates, one of my big frustrations has been some of this stuff doesn't integrate nicely into our Cube IDE or CubeMX. Some of the other partners, ARM and Kyle, again, we are using Atolic. They used to have ARM, Atolic, and Kyle, and they bought the Atolic uh, uh, guys. Uh, okay, oops. So one of the other things that's in the CubeMX, and again, we're using the CubeMX IDE, which has just the italic, so we don't have to switch between two applications. Some of the things that it has, of course, are code generation. We can add different software components. It's easy to go and configure all the different peripherals. You didn't even have to really think about it to generate the clocks. And in the past, it's been so complicated that they would provide an Excel spreadsheet with a bunch of macros to generate the C code for you because it was easy to mess it up and not even be able to blink a light. The documentation for the pinout configuration and just graphically able to see it and select what you want. Um, but it also has a power consumption calculator. There's a tab that you go and select and you say, I'm running on 3 AAAs. Look at the code I've written. If I'm asleep for this long and awake for this long, how many hours do I have to run on the batteries that I picked? And it will look at the code, look at what you're doing, and estimate how long you'll run on battery life. So then you can say, well, I don't want to use 2 batteries. Maybe I want to use, you know, more, so I might want to say, okay, instead of, when I'm in stopped or running, it says the current code I'm running on GPIO is 46 milliamps at 168 megahertz, and I'll drop, down if when I'm stopped, and then it'll give me, a graph of how long it's going to last. So that's over in the tools, and you get to select, what kind of battery you're running, all of that kind of thing on it. So it gives you those kind of tools as well. It talks about MPU, all of that, the different pinouts, again, the clock tree, all of that. The code generation. The code generation, that's over when we go on Project Manager. That's where you select. Do I want IAR compilers? Those are the different Kyle compilers. That's depending on the version, it'll either say Cube IDE or it might say Atolic. Um, this is another free one which uses the same GCC compiler, looks very similar. It's open. It's by a company called AC6. Oh, and there's Atolic True Studio by itself if we're wanting to use it, and just a make file. You can just have it. So let's say I'm uh, just want to do it on command line. So this develops all the tool. I go and change stuff. I can type make on the command line and it will go and compile everything not in the graphical environment. So you can generate all of these kind of options. We'll talk about make files uh, in the Linux course. When we start doing, you'll have to compile things on the command line, and as soon as you start getting more than 1 or 2 files, it starts to become awkward, and then you use make files, and we'll talk about that. Linux has many millions of lines of code, and it's something that you wouldn't want to have to go and compile the thousands and thousands of files individually, and so there are these make files that will automatically do all of that kind of thing. Here's a nice picture of what I just showed you where you're getting a graph and it's saying, hey, you're running for so long, you're asleep for so long, and tell me, how much the average current consumption. It says my battery life here is going to be 4 days and 5 hours. So if you're doing a battery powered device, you can optimize your code, go back and look and say, I need it to run on 2 AAAs. How can I change the batteries once a year, kind of, in order to make it a practical thing? So those tools are there, those kind of profiling tools. And again, it goes and it will grab the latest updates for you. One of the things, oh, this is showing you the AI application. And so it's saying, hey, there's different engines you can use. Again, you go into something like Google Colab, you generate a model or you use a model, it can take the model and shrink it down to fit it into a microcontroller. And so there's some, I used to have a lab that for you to do to be able to do something like that with temperature and things. Um, One of the other things, this is all based on a development environment known as Eclipse, and it's GCC based, and I'll show you some of that. And so a lot of different tools are AC6 that I mentioned is based on Eclipse. A lot of other companies' tool suites. Eclipse is there's Eclipse Foundation has this development environment structure to write Python code, C code, C++ code, JavaScript code, all sorts of different code. And so the same overall environment, Windows and things are what you've been using. That's an Eclipse based system. And so, we go into debug, it goes and opens the debug perspective. That's all Eclipse. You will find that same tool suite or very similar looking, maybe themed a little bit differently in different companies. They might be using Renaissance chips, for instance, and they have the same thing. You can have the same kind of environment, have Eclipse run and get, pick microcontrollers. And it's just plugging in the compiler and everything all into that environment. So you can use that. And again, free for commercial development in there because they bought Atomic for it. And so, um, again, code editor. So we'll leave all of that kind of stuff. You've been using that. We have, there are other debuggers, but this one is free and with it. This is the ST-Link debugger. Sager, the same company that we're going to use MWin from, has a debugger called J-Link, and it's a separate tool. And there's also something called um, uh, OpenOCD, which is a kind of a different variation. They're just a debugger, let you single step through code, but they have some have more or different types of features. You can put onto this the Sager. There's a version of their Sager J-Link to put onto this. Um, we won't be doing it, but you can, and then you have to make sure that you select instead of ST-Link, put Sager. The reason I mention all of this is sometimes you'll find some development, like a sample code, and you go to run it, and it goes, I don't know what you're talking about. It's because somebody was using either OpenOCD or the J-Link, and so it's not on ST-Link. You have an ST-Link that's by default on this, so you need to make sure that it says that. Again, if you grab a sample from somebody else, maybe that isn't there. The other thing that you can get with ST-Link is, or the new debugger on the back end, is you can do it remotely. So you could have something set up on a machine in a back room, for instance, with your target devices, and you can talk to it over TCP/IP and debug things remotely. The software viewer, we looked at the SWV console. There's also a SWV viewer, which is just giving you traces. So you could just do that right in the environment. I wanted you to use the monitor program because it gives you the whole Node-RED options to be able to do so much more with it. And so you can, if you just want to have a couple of graphs and see some plots move, that's just in the drop down where we did SWV data trace, SWV console. There's also the trace viewer here that will just show you a graph. But we can also then have the STM32 monitor and open it up, get our data into something that you can do post-processing on a PC with, okay? And also show gauges and all of that. So we're using that. Again, the programmer used to be, and is still available, ST-Link, and they've just modernized it and gave it a bunch more features called STM32 Programmer. If you're just doing debug, you don't need it. If you are putting a binary to give somebody, it drags and drops to that. You don't need it. You will find, for instance, if you use touch graphics is going to use that programming interface to actually program. So if you go and try and do it, it'll give you some weird error message, and it's just that it needs the STM32Cube programmer installed to be able to have the tools to be able to do all of its scripting and things. So, okay, so we'll continue on with more of this. It's basically talking about um, the all the different tools and environments that are available. We've been mostly ST, need to talk about a few others. Um, the ST Link, this is a Nucleo board. They're $9 onwards. This piece here is just what you have there, but it's perforated here so you can snap it off and put this into a project and not be taking up any battery life on there, and then use a standalone ST, which is kind of cool. Anyway, we'll continue talking about this next day. Thank you very much.